A converter is usually characterized by having an input amplifier, also input filters and output filters. A bare mixer is something we usually don't measure the noise figure on, because a bare mixer doesn't have any excess noise, so the noise coming out of it is just KTB level, and the noise figure is just 1 over the conversion gain. I'm going to first start with measuring the scalar mixer converter to make sure my converter is set up properly. And I've already preloaded the setups I want from the noise figure measurement, so I'll recall them here. And we can see the converter's response. So I'm going to add a new trace, and I'm going to normalize it. My current power is set to -25. Let's go down to we'll put a marker on this. 25. So let's increase the power until I see about a 1 dB compression. And it looks like around -15 dBm is the 1 dB compression. If I drop it down by -20, then I'm even only 0.2 dB compressed, and by -25, I'm pretty good. So that's a good power level to do the noise figure measurement at. Now that I've got first tested and made sure I can see my frequency converter, I'm going to bring up the noise figure on converters application, and we'll bring that up in a new channel, and I will again load that previously defined setup, and we'll take just a minute to look at it. So here I've got port 3 as my LO port on this frequency converter. You saw that setup earlier. The LO power is plus 10 dBm, and my LO is at 6.5 gigahertz. In the noise figure measurement, I have the choice of receiver gain. I'm going to start with high, but if you're not sure of how much gain your device has, you can start with low and medium. This sets the ambient temperature of the load for the scalar cal, and that's a kind of room temperature number. It's a good number to use, and I'm going to use a standard bandwidth of 4 megahertz. And of course I'm going to use the low noise receiver because I don't have so much excess noise. I've set the power of -25 dBm, and finally I'm going to do a linear frequency sweep, and I have the annotation set up to be the output frequency. So let's say OK. And already we're making a noise figure measurement. Let's put a marker on this, and we'll put it down at the bottom. It says about 6.97 dB. And the other trace I always put up is I put up the S21 trace and a third trace called the DUT relative noise power, and it's the incident. That means the power into 50 ohms. The SC21 shows me my gain, and it should be the same number that I get here, and it is the same number for the scalar mixer cal. And finally, when I go to look at the this is the DUT noise power. This is the noise power relative to the KTB power. So here it's putting out 21 dB above KTB. And it's good to know how much excess noise power you have. Go back to the setup, internal hardware, mechanical devices. And now both channels are set the same, and that means they'll both be able to sweep at the same time. I have a lot of confidence in my scalar mixer measurements. We've had that for years and years, so I'll do my calibrations in that. Then I can compare them to the measurements I get in the noise figure channel, and as long as those two align perfectly, I have a lot of good confidence that my noise figure measurement channel is set up and calibrated properly. And now we're ready to calibrate the noise figure channels.